Hundreds of pigs move forward, unaware that within hours they will become the bar of soap you rub across your face every day. The gate closes. The silence says everything. On the other side of the facility, tons of animal fat wait in refrigerated storage. Nobody asks where it came from. Hundreds of kilograms of fat rolling toward the heat. The first step in becoming soap. Then comes the second ingredient, caustic soda. A chemical so aggressive it burns skin on contact. Without it, soap would not exist. A single drop can destroy fabric within seconds. And yet this same chemical will help create the product that touches human skin every day. Animal fat on one side, a corrosive chemical on the other. When the two meet, something entirely new is born. Solid fat enters a heated tank and begins to melt, from solid block to liquid in minutes. Coconut oil is added to create rich foam. Palm oil provides hardness and durability. Every ingredient serves a specific purpose. Meanwhile, crystals of caustic soda are mixed with water. The reaction releases intense heat. The solution dissolves violently. 3 pipelines, 3 completely different materials, all entering the reactor at exactly the same moment. For the first time, fat and caustic soda come into contact. The reaction is immediate. Violent. The fat begins to disappear. The caustic soda begins to disappear. What remains is neither one nor the other. It is soap. Inside the reactor, temperatures exceed 100 degrees Celsius. The vessel vibrates as chemistry takes over. Fat and caustic soda battle until both are transformed. Every bubble is evidence of a chemical reaction in progress. The fat is destroyed, only to be reborn as soap. Too much caustic soda and the final product will burn skin. Too little and the soap remains greasy. The balance must be perfect. Slowly, the reaction begins to settle. The mixture separates into 2 layers. Soap rises to the top, glycerin sinks to the bottom. Salt is introduced. A centuries-old chemical trick. The salt forces the soap and glycerin to separate from one another. What happens next surprises most people. The glycerin produced during this process is often worth more per kilogram than the soap itself. In many ways, glycerin is the most valuable product leaving the factory. The same reaction that creates soap also creates the ingredient used in countless skincare products around the world. But there is one final problem. If even a single drop of caustic soda remains unreacted, the soap could damage skin. The solution is citric acid. It neutralizes the remaining traces of caustic soda, molecule by molecule. Only when every trace has been eliminated is the soap considered safe. Animal fat, vegetable oils, and one of the most corrosive chemicals used in manufacturing, transformed into a product gentle enough for everyday use. The chemistry is complete. Now the water must be removed. Ahead stands one of the tallest machines in the entire facility, 4 stories high. Its job is simple: remove water, and do it fast. The soap mixture still contains nearly 30% moisture. Thousands of liters are pumped to the top of the drying tower every hour. Inside, a vacuum changes everything. Under reduced pressure, water boils at much lower temperatures. No extreme heat required. Every drop of soap instantly begins losing moisture. Liquid droplets fall through the tower. 2 seconds later, they reach the bottom as solid particles. The vacuum performs in seconds what sunlight would take days to accomplish. The particles fall like snow. 30% moisture becomes 12% in only 2 seconds of free fall. At this stage, no one would recognize the product. No color, no fragrance, no shape, just pale gray particles of raw soap. Hundreds of kilograms per batch. Every container carefully according to its exact moisture content. From liquid to solid in a single pass. The tower has removed more than half of the water. 12.3% moisture. Too wet, and the rollers will jam. Too dry, and the material turns to powder. This is the true color of soap, a dull gray-brown. Without colorants, few people would ever buy it. Without fragrance, it has no identity. Without finishing, it looks more like industrial waste than a luxury product. On the other side of a single door, that is about to change. The material entering this room is exactly the same soap, the same formula, the same chemistry, yet one version looks like industrial waste. The other looks like a premium luxury product. The difference comes down to two things: color and fragrance. Nothing influences the value of a soap bar more than the way it smells. In some formulations, fragrance alone represents up to 30% of the total production cost. The scent is often the most expensive ingredient in the entire bar. Moments ago, these were gray soap pellets. Now they are about to receive an identity. This process is known as French milling, a technique perfected centuries ago, originally developed in 17th century France. Today, it remains the gold standard of luxury soap manufacturing. Hundreds of kilograms of gray soap pellets are poured into the mixer. The transformation begins immediately. A vibrant blue pigment touches the gray mass. Within moments, the original color disappears. For the first time, the material begins to resemble the soap consumers recognize. Then comes the fragrance. The aroma fills the room almost instantly, detectable from several meters away. By volume, it is one of the most expensive ingredients in the entire formula. Vitamin E, shea butter, aloe vera. Only a few grams are required. Yet these ingredients often cost more than kilograms of the base soap itself. Inside the mixer, powerful arms rotate in opposite directions. Every particle is constantly folded, stretched, and blended. The color penetrates every grain. The fragrance spreads throughout the entire batch. What emerges is blue and aromatic, but still rough, still far from luxury. The next stage will change that. 3 passes through a series of precision steel rollers, the process that separates ordinary soap from premium soap. Every luxury soap manufacturer knows this stage well. The difference can be felt immediately and seen instantly. Consistency is everything. The shade of blue must remain identical for months. A tiny fraction of a percentage can alter the color. Even the gap between the rollers matters, measured in fractions of a millimeter. That tiny distance determines whether the final bar feels like sandpaper or silk. A first pass begins. The rollers rotate at different speeds. The soap is compressed and stretched simultaneously. The rough particles begin to break apart. Lumps disappear. Color and fragrance distribute more evenly throughout the material. The soap enters with visible granules. It exits with the texture of soft butter. Nothing escapes the pressure. Nothing remains untouched. The second pass begins. The rollers move even closer together. Particles that were once visible to the naked eye become microscopic. The texture becomes smoother. The structure becomes more uniform. The fragrance becomes perfectly distributed. Then comes the third and final pass, the stage that defines true French milled soap. 1 pass, 2 passes, 3 passes. The difference is impossible to miss. The same material that entered looking like gray industrial waste now resembles a luxury cosmetic product. 3 passes have transformed everything. The texture, the appearance, the feel, the value. The ultimate test is not performed by a machine. It is performed by touch. If the soap does not glide across the skin like wet silk, the batch does not move forward. No exceptions. One final compression completes the process. A flawless ribbon of soap emerges, ready to become individual bars. Not a single grain remains visible. The surface is smooth as polished porcelain. French milling has transformed every particle, every molecule, every characteristic of the soap. Ahead waits another machine, the extruder. On one side enters a refined blue mass. On the other side will emerge an endless bar of soap, from gray pellets to a ribbon of silky blue soap. The French milling room has completed the transformation. Now industrial precision takes over. The extruder is the size of a car, a machine built for one purpose: turning refined soap into a continuous, uninterrupted bar. The blue soap disappears inside. A giant screw drags the material toward a high-pressure chamber. The pressure is immense, measured in tons per square meter. As the screw rotates, it forces out every remaining pocket of air. Even microscopic bubbles are removed. Vacuum systems extract what pressure alone cannot. A single invisible air bubble could eventually create a crack in the finished bar. That is unacceptable. The result is remarkable. An endless bar of soap begins to emerge from the nozzle, meter after meter, without stopping, without interruption, smooth as wet porcelain. Every centimeter represents luxury soap, a continuous bar with no visible beginning or end. Industrial-scale manufacturing captured in a single image. Hot air passes across the surface, sealing it instantly. The soap enters dull. It exits with a subtle shine. Precision now reaches microscopic levels. A difference of half a millimeter is enough to trigger an alert. Laser systems inspect every centimeter. Red beams sweep continuously across the surface, searching for imperfections invisible to the human eye. If a defect is detected, that section is automatically removed. No debate, no second chance. A fraction of a rotation more or less can alter density. Pressure is controlled to thousandths of a unit. The rejected section is instantly removed from the line, ground back into raw material. Return to production. Zero waste. Nothing is lost. The final meters of the endless bar approach the next stage. Ahead waits the guillotine, the machine that will finally give each piece its own identity. Too soft, and the soap will deform. Too hard, and it will crack. The ideal hardness exists within an extremely narrow range, from refined soap mass to a perfectly verified endless bar. Now comes the machine that will give it shape. Hundreds of bars per minute, this is where anonymous soap becomes a branded product. The guillotine operates at extraordinary speed. Each is perfectly measured, every bar exactly the same length. A clean cut, a new bar is born. Thousands of identical bars move forward in perfect formation, all waiting for the next step, their identity. Then comes the press. 40 tons of force applied to every single bar. In a fraction of a second, the transformation is complete. The soap yields under enormous pressure. A perfectly embossed logo emerges from the surface. 40 tons, every strike, every bar. The excess material is trimmed away and returned directly to production. A generic rectangle entered the machine. A branded product emerged. One single press created its identity. Before, an anonymous block. After, a recognizable product. The difference is 40 tons of pressure. Not every bar survives inspection. If a logo is off-center even slightly, cameras detect it instantly. Compressed air removes the defective bar from the line in milliseconds. The standards never change. Next comes metal detection, the same technology used throughout the food industry. Because this product comes into direct contact with human skin, zero tolerance. Even microscopic contamination is unacceptable. Weight control follows. Every bar is measured. Fractions of a gram matter. A lighter bar means rejection. A heavier bar means rejection. Only perfection continues. Then comes the oldest test in the factory. Human hands. Water. Foam. No instrument has ever fully replaced them. Dense foam. Perfect fragrance. Smooth skin feel. The animal, fat, and corrosive chemicals that entered the process hours ago have become luxury soap, stamped, scanned, weighed, and tested by hand. Every bar leaves perfect, or it does not leave at all. The laboratory has the final word. If the batch fails approval, nothing leaves the factory. No exceptions. The first test is pH, a value of 8.5, safe for skin. The second test evaluates foam production, above the minimum standard, approved. Hardness, color, fragrance, all verified in sequence. 5 separate tests are required before a single batch can be released. Inside a specialized chamber, Months of aging are simulated in only a few hours. If the soap changes color, the batch is stopped. If the fragrance fades, the batch is stopped. Nothing escapes inspection. Meanwhile, another product quietly leaves the facility. Glycerin, the hidden treasure of soap manufacturing. In some cases, glycerin is worth more per kilogram than the soap itself. Some people joke that this is actually a glycerin factory that happens to produce soap as a side business. Every rejected gram of soap is ground down and returned to the beginning of the process, zero waste, across the entire facility. The same base formula can create multiple products: standard soap, floating soap infused with air, and medicated antibacterial soap. 3 production lines, running side by side. Laboratories, glycerin recovery, recycling systems, an entire world of science hidden inside something as simple as a bar of soap. Now comes the final stage, packaging. Thousands of bars every hour, wrapped in a fraction of a second. The speed of industrial packaging is almost impossible to follow with the human eye. The wrapper serves a purpose beyond appearance. It protects the fragrance for months. The first thing consumers experience when opening a bar is its scent. That moment was designed here. Every bar receives a unique code, a code linking it directly to the exact batch of fat, oils, and caustic soda used to create it. Full traceability, from raw material to finished product. 6 bars enter every carton. Robots pack them continuously, without stopping, without making mistakes. Millions of bars sit inside a single warehouse, waiting, ready to be shipped to more than 40 countries. Every day, trucks arrive. Every day, trucks leave. The first stage of a journey that ends in bathrooms around the world. A single bar sits among dozens on a supermarket shelf. Ordinary, familiar, forgettable. Almost nobody imagines the journey required to place it there. From the steel machinery of the factory to the shelves of a supermarket. A process that began with animal fat and caustic soda ends here. 7 billion people use soap every day, making it one of the most universal products ever created. The journey continues across oceans, from factory to port, from port to cargo ship, from cargo ship to distribution center, from distribution center to store shelf, the final stage before reaching human hands. The package. For the first time, the fragrance escapes. The soap touches water and fulfills its purpose. A hand, a bar, a simple gesture repeated billions of times every year without a second thought. White foam begins to appear, thick, rich, exactly the same foam tested by inspectors inside the factory. Now in the hands of a consumer, hours of chemical reactions, vacuum drying, French milling, laser inspection, and 40 tons of pressure, all culminating in 10 seconds of running water. 7 billion people, 1 bar a day, and tomorrow, the entire process begins again.